GMAT all day.
As promised, here is a bonus video. Let's reconcile our cheat sheets for quadrilaterals and polygons. So our first item in our list says the hierarchy for quadrilaterals. So I can recreate this diagram from memory. If we start with just a quadrilateral, well, that is just any shape, any polygon with four sides. Then, once I have a quadrilateral, I can get a parallelogram. So how do I do that? A parallelogram is going to be a quadrilateral where opposite sides are parallel and equal length. And then it is also true that for a parallelogram, your diagonals are bisectors. Of each other. What this is saying is both of these things are true about parallelograms. Their opposite sides are parallel and equal length, and their diagonals are bisectors of each other. However, to go from a quadrilateral to a parallelogram, we only need to know one of these things. Because if we know one of these things, well, the other thing is necessarily true based on that. Well, now once we have a parallelogram, the next step is we can get to either a rhombus or a rectangle. So a rhombus is a parallelogram, which is a quadrilateral. A rectangle is a parallelogram, which is a quadrilateral. But a rhombus is not necessarily a rectangle. So let's start with a rhombus. How do you get from a parallelogram to a rhombus? So for a rhombus, all sides are equal. You also know your diagonals are perpendicular bisectors of each other. So just like before, both of these things are true about any rhombus. However, to get from a parallelogram to a rhombus, we only need to know one of these things to be true, because the other thing will be necessarily true based on that. And to get a parallelogram that is a rectangle, we just need to know that a parallelogram with at least one angle that is 90 degrees. So even though for a rectangle, all of your angles are equal to 90 degrees, if you have a parallelogram and then you know that just one of those angles is equal to 90 degrees, it is necessarily true that all of your angles, the rest of your angles, must also be 90 degrees. Otherwise, you would not be able to close that polygon. But when you have a rhombus and you put it together with a rectangle, what does that give you? That gives you a square. So there is nothing new contained in a square. It is just the properties of a rhombus with the properties of a rectangle. So all sides are equal. Diagonals are perpendicular bisectors. And just like with a rectangle, all of our angles are 90 degrees for a square, but we just need to know that at least one angle is 90 degrees. And then we know that the rest also have to be. So if we have a rhombus and then you find out that one of your angles of your rhombus is 90 degrees, well, that rhombus is now a square. And if you have just a rectangle, and then they tell you that the diagonals of that rectangle are perpendicular bisectors of each other, well, now that rectangle is also a square. Perimeter of a polygon. So I guess let's just start with our quadrilaterals, because that's what we talk about in our videos mostly. If we just have a square and we know all the sides of our square are equal, so if each side here is x, the perimeter, that is just the distance around your square, should be 4x. So if we have a rhombus, so with a rhombus, same deal. All of our sides are equal to each other. This should also be 4x. Now with a rectangle, the rectangle has a length and a width. Since opposite sides are equal, because a rectangle is a parallelogram, our perimeter here should just be 2L plus 2W. Now, if we have just a regular parallelogram and we don't know necessarily that it is a rectangle, I wouldn't say this is 2L plus 2W, because I don't think this is really, if we say this is the length, this isn't really the width, because it's on a slant here, and so your width is really more like the height, would be this guy here. So you almost have to think of a parallelogram. Just call this side X, this side Y. Your perimeter is just 2X plus 2Y. Then you can continue doing this for any type of polygon. We'll do one level up. So if I have like a pentagon, perimeter is just the length around. So if I say this is A, B, C, D, and E, if it's a regular pentagon, these will all be the same. If not, your perimeter is just A plus B plus C plus D plus E. Some of the angles of any polygon. Let's start with the ones we've been doing commonly. So triangles, these sum to 180 degrees. And then for quadrilaterals, so it doesn't matter if it's a isosceles triangle, an equilateral triangle, a weird looking triangle that doesn't have any type of name, the angles always sum to 180 degrees. Same thing with a quadrilateral. Doesn't matter if it's a square, a rectangle, a parallelogram, a rhombus, or something else. If it has four sides, the angles are going to sum to 360. So then you can find the sum of the angles for any polygon, no matter how many sides it has, with this formula. This is really the sum of the interior angles of any polygon. And that is just equal to n minus 2 times 180. So I don't know if we went over this in the video series, but this comes up sometimes, useful to know. And n is just refers to the number of sides of your polygon. We can check this out for triangles and quadrilaterals. So for triangles, they have three sides. So 3 minus 2 times 180 is 180. So that works. And then for a quadrilateral, 4 minus 2 times 180. So if we had a pentagon that has 5 sides, that should be 5 minus 2 times 180, or 540. It goes up by 180 every time. But you can just use this formula. So if you have a polygon with 52 sides, you can use this to find out the sum of those angles. Area of a rectangle. So that is just length times width. Area of a parallelogram. And so here, the length times width for a rectangle, you can really sort of think of it as base times height. But for a rectangle, you say the length is the base, well, its height is the width, because all the angles are 90 degrees. So for a parallelogram, it still really is base times height. But if I say this guy here is the base, this here really isn't height. So you wouldn't want to do that. You would have to find the height here. This line. That would be the height. The area of a trapezoid. I don't think we talked that much about trapezoids. Trapezoids look like this. So you have two sides here that are parallel to each other. And the area for a trapezoid, we have two sides here that are parallel to each other, and then these two sides here are not parallel to each other. But the area of a trapezoid, that is also just really base times height. So the problem here is we have two bases, right? Our bases have two different lengths. So if I say this is B1 and this is B2, when we find base times height, it's really sort of like we need to find the average. of these two bases. So it's b1 plus b2 all over 2 times our height. Now also remember, so our height is not one of these lines here. The height for a trapezoid, that would be something like this line here that forms a 90-degree angles with this b1. Commonly, it will ask you for the area of a trapezoid, but you don't necessarily need to use this formula, or you might not be able to use this formula. So I've seen a lot of questions where they have a trapezoid that's buried within a triangle. I'd ask the area of this trapezoid here, and if you can't use this formula, because for some you can't figure out what the height is or what the length of your bases are or something, well, there's another way you can do it, and that is you got to find the area of your big triangle and then subtract out the area of that triangle here, and then you'd be left with just your trapezoid. Don't over-rely on this formula. Surface area of a cube. We have two types of cubes. If we have a regular cube, meaning it's just made up of a bunch of squares. So this cube, think of it as having 6 panels, front and back, top and bottom, left and right. Those are all the same. Say each side for our cube is just a length of s. Well, since it's all the same square, back, front, top, bottom, all the same thing. So the area of one of those squares is just going to be s squared. Therefore, the surface area of your entire cube is just going to be the sum of your 6 squares, or 6s squared. Now, if you have a irregular cube, or sometimes they'll call it a rectangular cube, these are less common than regular cubes, but I've seen them asked about before. So that would be something like this. Now, all of our sides are not squares, they're just rectangles. So in this case, we want to find the surface area. We're just summing up our 6 panels, but now they're not all going to have the same area. So if I think of, I have some length here, and there's some width. And we'll say this is x, this is y, and our depth here is z. So when I want to find the surface area, I can sort of divide my panels into top and back are going to be equal to each other. My 2 side panels will be equal to each other. And then my top and bottom panels will be equal to each other. So for my front and back panels, those are just going to have an area of x times y. But I have 2 of them. I have a front and a back. That's just 2xy. Then it's going to be plus my side panels. So each of those are going to have an area of y times z. That's 2yz, because I got 2 side panels, plus my top and bottom. So the top and bottom panels, those are going to have an area of yz as well. I'm sorry, those are going to have an area of xz. 2xz, that's my top and bottom. This is how you'd have to find your surface area if you did not know you had a regular volume of a cube. So we can do the same thing if it's a regular cube made up of all squares. So yeah, the volume for any cube, regular or irregular, is just going to be length times width times depth. But with a regular cube, those are all the same. Just think about it as s cubed. And for a rectangular cube, here you actually have to think of it as a length times width times depth. It's going to say x, y, and z. We're not finding area, we're finding volume. The diagonal of a square, this is not hard to do. One thing to remember, so with a square, when we make our diagonal, that diagonal is going to split these edges evenly into 2 45 angles, which is going to give us a 45 45 90 triangle over here and over here. So what that means is if this square has a side of length x, this is also x, your diagonal should be x rad 2. So with a rectangle though, a rectangle that isn't necessarily a square, if it's not a square, this diagonal here, even though it might look like it's still the case, it will not split this angle here into two. It will not bisect it into two 45-degree angles. And so do not assume that. So for this, if we have, this is our width, this is our length of our rectangle, you can really just say for your diagonal, just got to use Pythagorean theorem. And so Pythagorean theorem in this case would say w squared plus L squared is equal to your diagonal squared. This is just D, this is your diagonal, so that would just be equal to the square root of W squared plus L squared. This triangle here, it would not be a 45, 90. Don't make that assumption unless you know you have a square. And that is it for quadrilaterals and polygons. On to the next geometry series.